Oh, hi, Martin.
Hi, Martin.
Hi. How are you feeling?
Better, but there's definitely better things than being sick in summer.
Yeah.
It's the whole Corona. It could be Corona stuff. I don't know, but it's
I'm pretty sure it was in my case, but I don't know in the end.
Yeah, I've heard that from quite a few people. It's starting to spread again.
Yeah.
yeah. It's strange. So before Corona, it's definitely there was not definitely me. I didn't have so many flus.
No.
Because we isolated ourselves.
Yeah, but I mean before Corona started, nobody isolated then. But then I don't remember like so many flu infections.
Yeah, because you were immune.
And it's pretty uncommon for those viruses to be around in the summer, but apparently Corona is a little bit different.
Yeah.
I mean,
Anyway,
I don't know because nowadays you don't really do tests anymore, so could have been
No.
anything. But it's
Yeah,
like,
but a regular flu usually doesn't occur as much in summer.
Yeah,
it's autumn. Yeah, it's autumn typically. But somehow Corona is very active in summer. I don't know.
Yep.
Oh.
Hi, David.
I
Hey,
did it.
folks. Sorry, I was not here last week. I also was sick last week. Not Corona, I don't think.
Link, are you back to 100% already? Or
Yeah, I'm back to 100%. I think it was allergies. I think at my advanced age in life, I feel like I don't really get sick anymore. But the Lord giveth and the Lord taketh away, and so I don't get sick anymore. But now I have allergies, which I didn't used to have.
yeah.
So
Hi, hello.
Hi.
Allergies. Yeah,
yeah.
I hate it.
Yeah. We could probably fill the whole meeting with like all the illnesses and inconveniences we've encountered.
Also, if anyone if anyone has children, they're also little germ factories.
Yes, but I'm so I have three kids,
Yeah.
and the most sensitive phase is when they go to kindergarten the first time. It's
Yeah.
like they infect the whole family.
Yeah, patient zero.
We are still waiting. Oh, Jeff is here. Okay. Okay, I think we are complete. Is Derek coming? Anybody knows?
I'm not sure. I don't think he was on the agenda.
No, he's not on the agenda.
But he did respond to the thread, so
Yeah, that's why. Why I asked, because he said it. Let's discuss it tonight.
Yeah.
I'm gonna ping him, but we can anyway. Start in a second. Okay. Okay, let's start. And let me all remind you, by being here, we all agree to the GraphQL Spec membership agreement and to the GraphQL Foundation Code of Conduct. We have three things on our agenda that we're going to talk today about. It's because it's a primary. We quickly do a review of previous progress. This is also good for you, David, because you missed the last meeting, so we get you caught up. Then we continue the discussion that David started on GitHub. I put 20 minutes on it. I don't know if we need that much or if it's longer. Doesn't matter. And then we could start continuing on the composition part of the spec, if time is left. So originally, we also planned to bring the spec parts that we so far completed or complete discussions on to the main working group. We're not going to do that this week because there's a bit more polish on the spec text needed, and I was out, and Pascal also was out the last couple of days to finish that off. So we can do that either in the secondary meeting if there is one, but there's also the problem that I saw that people like Benji, for instance, he's on holiday, and there might be also others on holiday in August. So we could take September, where most of us anyway are at the conference, right?
Yeah.
And then we could.
Sounds perfect.
Yeah, there was anyway the plan. I will talk to the others about it, that we have like an open working group at the conference where people also can join, and then we can do a presentation. This could even be the opening for the whole composite schema specification thing at the conference. Could be a good discussion.
Because I think it's the working group is on Thursday, so that would be the second day of conference. So it's more like it's going to be the closing of the conference because, or is it? No, that's not true. No, it is.
I don't know what that it might be that we put it on an odd day because we also have a governing board meeting there, and I don't know on which day they put it. I think it's pre-conference, but yeah.
It might actually be good if it's after the presentations because that gives people an opportunity to get caught up and sort of join in on the discussions, think a little bit about it.
Yeah.
I think that if we present it there, it's also a really good insight into what the working groups really do, because it's really spec heavy and it's really theoretical, while the presentations and the other
it's more compressed. Yes,
it's more compressed and more usable. The working groups is often like not usable, practical. That's what I wanted to say. Practical than the theoretical. Yeah. Anyway.
Yeah, but you're right. Sometimes the discussion in the working groups are difficult to follow. But in this case, like we are also presenting to the members of the TSC that are in the main working group that might not be involved in all of the composite schema working group work so far. So it could also be nicely consumable for people that never were at the working group. But anyway, I will propose this to Benji then, and he can put that to the because he's on the conference team, and then they can discuss it there. Okay, so let me give you a quick refresher on the past work we did. Yeah, quickly. New one. Okay, can you see my screen?
Yep.
Okay, so this is the composite schema spec. We have actually two parts, and the other part is not merged in this PR that I'm on. Is the appendix that Pascal worked on, the syntax that we, I think, put a ton of work, more work than I initially thought in, and which has now a pretty good state. But the other part we talked about also last meeting was actually around the directives that make up the source schemas, and that are the high-level things people will use to define their source schemas and how the source schemas compose into the composite schema. So one of the main things, and that might also factor into the discussion of that David started, is a new approach how we expose essentially lookups in schemas that are the things that the traditional Apollo Federation specification used in underscore entities for. And that makes it a lot more flexible how you integrate schemas into a composite schema. So this is very entangled with the syntax discussions we had, because the lookup, simple lookups, you could just annotate with @lookup, and then they become lookups. These are entity resolvers. If you don't understand the lookup concept yet, it's basically a way to resolve an entity by a stable key. And that is the core really to the composite schema spec, how to resolve other entities and how to compose them together. There are, I'm quickly going over that. We are not going into the detail that we did last week, just so everybody gets an idea. We also have a directive called internal that is in combination with lookup, and it allows us to have lookups that are internally used to resolve entity parts. And with that, you can control if a lookup is also an entry point and exposed on the public available schema that clients are using, or if it's just a technical way to resolve an entity. If we have more complex lookups where there is mapping needed, or where the arguments here don't align with keys, keys basically are fields on the entity itself that represent the stable key, then you can use this is directive with the selection pass mapping syntax that we have, that allows us to express semantical equivalence, but also describe the mapping process. How do we get the data from the output type, map to the input type that we have here, in this case, a simple ID that is pulled up, for instance, from an object address that is on the person entity. The same goes for the require directive. Require directives is to express data requirements. And there we have the same field selection map syntax that I explained, where, and I can show a more complex mapping here, for instance, where we map from the dimension object, the size, to basically flatten the object a bit and map that here to the input as a data requirement for a field.
Yeah, and maybe to mention, this is another example of a simplification from the current version of Apollo Federation, where we had a requires directive, and the information that was required was passed through sort of untyped through the underscore entities field. And what this mechanism allows us to do is use normal GraphQL arguments and query variables to pass that information through instead.
Yes, and that's also like these two things, like lookup and requires, allow also for a much broader application of this specification. You don't need to necessarily introduce these internal resolver structures to your GraphQL schema. Yeah, and then we have the more classical directives key, and that's what I mean. There's polish missing. There's a bit text missing here still. That is a classical Apollo Federation directive that is also available in the current Apollo Federation implementation. Same goes for shareable, which allows us to define which fields can exist on multiple source schemas. Like if you have a normal entity or any GraphQL object, then it's not allowed to bring over or to have duplicate fields on different subgraphs. The exception is with keys. All keys are shareable by default, but for all other fields, you have to declare that and make it a conscious decision to bring or to optimize certain fetching patterns between entities. Same goes for provides, external, and overrides. These are also like directives that we just took one-to-one from the Apollo Federation specification. There's a bit more text needed that I have to write the next couple of days. But this is the set of directives which we agreed for the version 1 of this specification. And I think it's a good set, it's a good starting set to keep the initial specification still simple and to deliver it in a reasonable time to people. And there is no, like, there could be other directives, like Apollo has a ton of other directives that are provider specific, and that is also okay with the specification. Maybe we should have that as a note, like that you can extend on top of that. I will add that too in the directives chapter. That's a bit for what we worked on the last couple of meetings. And with that, we can go into the discussion of David. Maybe if there are no questions to this. Other question to this? The review? No? Okay, then we can go on to the discussion that David introduced. Maybe, David, you can repeat it to people that didn't read it.
Sure. Let me just paste the discussion into the chat. This is mostly just an invitation to it's a bid to kind of understand what the experience and approach is for this topic. It's really around, you know, how to combine arbitrary schema. I encountered some verbiage in the composite working group spec, which, you know, stipulates that the spec doesn't really address combining arbitrary schema, which makes a lot of sense to me. Like, I totally understand that. But I wanted to understand, you know, I've taken a few runs at the spec. I can do a much deeper dive on the spec, but to try to understand what have been the experiences of people in the working group on this subject, and is there any prior art on the subject, and what some recommendations are. And in detail, the kernel is sort of by my lights, which could be entirely incorrect. I've taken a few runs at the spec, like I said. The composite working group, essentially it's information which describes how to compose subgraphs, and that information is, I think, embedded in the subgraphs as directives. Are there, you know, what are some other approaches, if at all, for where to put that information, right? Does that information, can that information be somewhere else besides in directives? Could it be in a database somewhere? Could it be in a gateway? I think, Martin, you had a comment which I liked. You raised the possibility of an overlay. I think in the description that I had, I gave the example of GraphQL mesh, which I think has a federation transform, which can take an arbitrary schema and essentially overlay the directives. Maybe that's an approach. Another possibility.
I had something more specific in mind.
Yeah,
that might be good to mention that. And like Fusion actually had an implementation.
Yeah, that's right. I forgot to mention that.
It's I think like relying on directives is something we would probably recommend over like additional configuration formats, because we already have the semantics and the typing. But that information could definitely live sort of outside of the regular schema in like a schema extension. Doesn't have to be a file. Can definitely live in a database. But we want some mechanism to sort of apply directives to an existing schema, to sort of overlay them on top of an existing schema.
Yeah, that makes a lot of sense. And by the way, again, I understand the merit in like a focused approach. So for instance, if the working group decides that this is a runtime concern or an execution concern that's outside the scope of what we're trying to do here, that's cool too. Just trying to understand what the status is. But again, and also if the view is effectively there are directives, but then how you arrange for those directives to be there is again an implementation or a runtime detail, that's fine too, right? Like if it's extension files or a gateway or something. I don't know what are.
Yeah.
This is mostly a
Come-
bid for just discussion, so I'll stop there. I see
Kamil,
Kamil has a comment.
Yeah.
Oh yeah, I just wanted to say that like from my perspective, there's like the pretty much the split between those two approaches is like who owns the configuration, like how do you merge, like who owns that part, right? So like we've been there with like stitching and with mesh, for example, from our experience, it was a bit cumbersome from our point of view that like whenever something is on the gateway, all the teams have to maintain the thing on the gateway about like it really boils down from our perspective to ownership. And then the ownership, like if you have a gateway and there's like plenty of teams, it becomes a problem at some point, but not in all cases. Like sometimes, you have a team that actually controls, like has this arbitrary schemas that, those teams are fine actually, like, mapping different types together, stitching it all and so on, right? So I would say like, yeah, also like very much the difference is like if the team builds a subgraph or like a GraphQL, then they pretty much do not care about the rest of the subgraphs. It's like it's not like a complete isolation, but like semi-isolation, I would say. And they ship whatever they want, and then if they want to contribute, like for example, share the same type, they just name it the same, and then it's done, right? Like speaking very shortly. But on the other approach, you would have to like, apply that thing at the gateway level, like probably map it or like, turn one name of the type into the matching one just to merge it and things like that. So yeah, for me, it's like the difference. And I think like in this composition working group, we actually want to like help people build the, schema together and not like have schemas and stitch them, like at least from my perspective. Like that's my contribution.
Yeah, so we by the way discussed this, right? We discussed also transformations and things in the beginning, and we decided that transformations live somewhere else. Not that they are forbidden, like they could be pre-processing or whatever in your proprietary solution, but the idea of the specification is that people can build their subgraphs with this specification, and there's a set of rules how we will compose these subgraphs into a composite schema. We don't want to necessarily say you have to do it like that. You could have also a different set of directives in your own solution. You pre-process it to the standard defined directives, and then the standard compositional process from the composite schema specification would work. And last thing is also we don't prescribe that the composition necessarily has to happen at build time. Many solutions do that. We do that, but you could also say in the case of Hasura, you do runtime composition, but with the rules that we defined in the specification.
Yeah,
Martin.
Yeah, I wanted to say something else, but maybe on this last topic. I think it is important to emphasize that the composition rules, those are part of the spec. So it it describes how a subgraph sort of presents itself. It describes how a subgraph schema gets composed into an overall schema, a federated schema. It also describes in some detail sort of the semantics of distributed execution, like how you enter a subgraph how you get information from one subgraph and pass it through to another. Like that's all part of the spec. But there's a lot of flexibility in sort of where composition happens, where the source information comes from, and also how execution happens, like whether there's a query planning process, what kind of optimizations get applied, even the transports are sort of somewhat open. So I think there's a lot of flexibility there. What I wanted to say on the topic of metadata is well, basically that I think there's a whole discussion to be had there, because there is a lot of value, but also I think the current approaches are pretty limited. There are many different kinds of metadata. Like some metadata really sort of belongs to a GraphQL service, to a schema. Like, and I would say like preferably something like a key or a lookup, like that really is part of the main schema definition. But the way we, with Apollo Federation, for example, use directives is also a way to specify like additional composition or runtime semantics. It's basically information that other parts of the like other parts of like composition, query planning, execution can take advantage of. And some of that metadata could very well live outside of a particular service, and it's probably preferable for that to live somewhere else. Another area of metadata that we really haven't discussed, that we have a sort of solution for, but I think we've sort of decided to keep that out of the spec for now, is namespacing and versioning of directives. Because as soon as you sort of open up these directives, as soon as people start like adding additional directives, and we've definitely done that with Apollo Federation. Like there's the possibility of name clashes. There's versioning issues. Like you have to know that a gateway or router, for instance, is able to actually interpret the directives that you're using. So ideally, I think we'd find some time to like discuss an approach for that as well, but we probably want to keep it outside of the main spec for now. It's more general, and I think there's also a broader group that would be interested in something like that. But it's definitely like on our mind.
Yeah, that it's just before Pascal, I give up to Pascal. It's also discussed in the main specification group. Like there is some movement on that. We recently discussed pragmas as a way, but this also was just another iteration on the whole discussion of metadata, and namespacing as well is also a core GraphQL concern that is being worked on or discussed. Pascal?
Yeah, I mean my point is more that you most likely don't even need, or you can have additional directives. It's not forbidden, but in most cases you probably do not even need it if you bring it in some kind of subgraph format. So when you, for example, want to map in a database like you do, or you want to map in REST services, whatever, as long as there's a preprocessor which outputs a, from the gateway, understandable subgraph schema, which is just a data contract, more or less, right, with a few annotations, you can contribute to this public schema without having the gateway to understand more complex directives. I mean, if necessary, they can be necessary. But for example, for a simple REST API or something like this, you can also just infer a like graphical schema out of it, because in the end you expose it. REST has a few more capabilities in some areas than graphical has, but in the end it's going to be anyway a graphical schema. So as long as you put it into the subgraph specification, as long as it looks like a subgraph, the gateway can work with it. And I would also like to touch on the thing that teams work in isolation. I think that's correct, but it's more that they want to work on the same domain, so that you have a public schema which the teams actively know and want to contribute to. because you have to know when you do federation, that's also what we see with our .NET people, where they build microservices in complete isolation. Then you tell them that they actually have to extend the type which is not in their aggregate. Then they get a bit nervous. But the idea is that you basically contribute to the overall domain, so it's fine that you have knowledge about the other subgraphs because it's the same overall domain. Anyway, that's it.
David?
Thanks. That makes a lot of sense. I just sort of repeating back what I've heard. I think what I'm hearing is the composite working group spec describes the process of composing subgraphs that are compliant with the spec. How you get a subgraph that is compliant with the spec is another matter. That could be arranged in a million different ways, preprocessors or gateways, and arguably is outside the scope of specifically what this working group is working on. That makes total sense. Is that fairly accurate?
Yes, it's a conscious decision where we said, okay, this is out of scope of this working group to define how a database translates into a subgraph or how a REST endpoint translates into that, right? That is something that the companies can innovate on. Like Apollo could have a unique approach to that, or Hasura could have a unique approach to that. There's the way, for instance, Mesh does the REST to GraphQL mapping. And that's not what we describe. We more describe how the schemas, the resulting schemas, can compose then into an overall graph. But we don't do heavy transformations like we have the field selection map syntax, which does some sort of mapping, but like heavy lifting, rewriting types and stuff like this is where you can innovate on.
Cool. I'm satisfied. We can keep discussing this if you like, but I think I understand it. What I'll probably do is, I've neglected to volunteer to take notes for this meeting, and I'm not sure anyone is taking notes, but
no,
from memory, from memory, I'll write up what we've discussed here, drop it into that discussion, and then that'll be it.
And I'm just curious, maybe as a last question, like how do you see this approach fitting in with the approach you've taken so far with Hasura?
I think pretty well. I think I think pretty well. I hadn't even considered preprocessors, but that's an obvious approach. There's GraphQL Fusion, there's GraphQL Mesh, there's what Hasura does. I just like that there are a variety of options there. As you probably know, Hasura works with a lot of enterprise companies who have sometimes dozens or hundreds of business domains and thousands of types, and they move at a glacial pace sometimes. And getting them to like wrap their heads around GraphQL in the first place is a heavy lift. So when we ask them to, just getting them onto GraphQL is an accomplishment. Asking them to then adapt their schema, they're like, what? So I think this fits really well.
Come in.
Well, Pascal was first.
Okay, sorry, Pascal.
Don't worry. Yeah, we also see that when we have with Chocolate, we have the capability of also mapping more or less databases into a schema. And what we often see happening there is that the schemas are heavily orientated on database design and how these things. The schemas are really complex to understand, and what I see with our federation customers is that they can have dozens of subgraphs, but they compose into a schema which is still like a very, very easily good understandable graphical schema, and the domains are just composed out of the different subgraphs. So I think iteration speed often comes at the cost of like quality, I would say. I know that you guys did a lot, and I was really happy to see that in reshaping, so that you have like a relay compliant schema composed out of different databases and different sources, which is really nice. But yeah, that was just my 2 cents.
Makes sense.
I just wanted to say that like about like pre-processing and stuff. So we already do that, like, or started doing that for mesh. So what we do is if you have a source that is like not federation subgraph, let's say, or not even GraphQL, but we define the entry points and then we turn those entry points into like entities and stuff. So, and if something requires like additional logic, then we apply like directives that lands in the supergraph and then mesh understands it and so on. So it's like a thing built on top of the federation spec already. And it works great because like if you have a subgraph that, you know, is like a virtual subgraph, I would say, then, you know, you just like, for example, in our case, we like publish it to Hive and then like a schema registry, let's call it. And then, you know, the mesh as a gateway pulls it, and then it's like a virtual. It has a URL, but it has no really like a, you know, like a GraphQL runtime, I would say. It's just like a pass-through, just defines the contract, and that works great. It's not like extremely ideal, I would say, but it works and like leverages the composition and satisfiability and so on. So it's like, I don't know, I feel like that from our perspective of the guild, like we would love to have this spec that we're currently building, that we can like extend and use what we do currently and just, you know, leverage the same logic, the same validation rules, and extend it if needed. That would be like, I don't know, extremely lovely.
Yeah, and it's a minimal set of rules that we all abide to at some point, and then tools are more exchangeable. You can take your subgraph that you built with mesh, move to Apollo Federation, or the other way around, and it just composes.
Yeah, and I think one of the benefits of like a shared understanding of what we're trying to accomplish and a shared specification is we can also educate people and collect best practices. And I think one of the things there, and I think Camille sort of hinted at that, is like subgraphs are, I think first and foremost, sort of an organizational unit. They're really meant as sort of an area of responsibility. There's a team responsible for a certain part of the graph. And the subgraph is a contract between sort of that team that may sort of own some underlying services and the overall graph. And as part of that sort of boundary, you wouldn't usually want people to just expose their services as is to the world. You're not like exposing your current REST APIs or your database directly. But there's some kind of like mapping layer in between. And that's where like there are dozens of approaches in sort of how you define them, kinds of workflows you enable, what happens at runtime. But in the end, I think conceptually, what we're asking people to do is sort of think very carefully about like what they're exposing to the world and how that fits in with the overall graph that their products, their clients rely on.
Makes sense. Makes sense. Thank you, folks, for indulging me. But again, I'm satisfied.
Awesome. No, it was a good discussion. We had this discussion in the beginning, I think, where we started sorting out what we're gonna do, what will be part of the spec. But it's good to also everybody gets his thoughts in again and get that more clear in the group. Awesome. With that, we can move on to the next point on the agenda. Pascal introduced it about the composition. Pascal, do you want to take over discussion?
Yeah, I mean, I just put it there and put my name behind it, but in fact, I don't have the notes. I believe you made notes last time. The idea, or what we started in the last meeting, was starting to structure the composition a bit. So just the documentation section. I think we have now all the headings that we want to have. So we have a structure of how the composition should happen. We have the source schema validation. By the way, if I say something wrong, please just interrupt and correct me. We have the source schema validation, which validates a subgraph schema in isolation. Then we have the whole merge step, where we do a pre-merge validation. This pre-merge validation already has the context of all the subgraphs, but doesn't have the composed schema yet, the merge schema yet. The reason why this step is needed is because we have the case where, for example, source schema validation does the graphical validation plus a few extra things. Pre-merge validation now knows all the different types in all the different subgraphs. So can, for example, check if you have collisions in fields. For example, you have defined the name as a string in one subgraph and as a Boolean in the other subgraph, something like this. This wouldn't merge, so you can already have this validated before you merge. Then you do the actual merge, and I believe that we said that the actual merge should always complete. Otherwise, otherwise we miss a pre-merge validation. So once we have the pre-merge validation done, we need to be sure that we can actually merge the schema. And then we merge the schema, we compose it into one supergraph, or however we call it, the composed schema. And then after this step, we have the post-merge validation. And these are all the validation rules which need to have the knowledge of all of the composed schema. One of this example, which makes a lot of sense, is, for example, require, where you have to know where you can require fields which you do not know from other subgraphs. And if you want to do this before you actually merge, you have really weird validation rules, because you basically say, give me all the type persons, and then give me all the type with name persons, and then merge the type to see if the fields are there. So that wouldn't make sense there. So we have this extra validation step after the actual merge, where we validate that all these rules are valid. And then, as the last step of the composition, we have satisfiability, which basically makes sure that all possible queries are executable and do not lead to runtime issues. And that's the composition. Now, what we should do, I believe, are there any questions? Did I say something wrong? Do you all agree? Did I miss something?
No, what's good summary, Pascal?
So I think what we can do in this session, as we still have 20 minutes, would be to talk a bit about what's in these chapters. So do some specific bullet points, what category of rule or what rules should be in the specific sections, because that makes it a lot easier to write the spec text later.
Yeah, and let me actually pull this in here.
Yeah.
And this goes here, because we have a couple of rules that we had on the core spec text, and maybe there are already a couple that we can at least on the header agree on. And then
Command B.
What?
Command B.
Yeah. And Command J. Okay, so we have maybe for the first thing here, this is the validation in isolation. We don't have to specify here that's a valid GraphQL schema. We just will introduce, okay, we expect a valid GraphQL schema in the sense of what is allowed under the GraphQL specification. What this chapter should validate is that the directives, how they are applied to subgraphs, are in a valid state or whatever. but we don't have to validate that an object type has unique field names or whatever. That is part of the graphical core specification. We can refer to that, but we don't have to repeat them. Let me just quickly run over this. So what we have in the specification text we had so far, and don't worry about error codes here. We should define them, but these are just what we had in the first iteration of this. So we're gonna. I think the sentiment was not to have numbers, but like the graphical reference implementation, have more semantical error codes. But anyway, so we have a couple of rules. A couple of them will be outdated because we worked on a couple of aspects. For instance, this one, semantical equivalence, I think.
That would, for example, be an example for a pre-merge validation rule.
Yeah, that would go in this one. Let type name be a set of all types across all subgraphs involved in the schema composition by their given type name. Given each pair of types, type A and B, and type names type A and type B must be the same type kind. And that means that, for instance, these types would merge. These types would merge, but if user is a type or a scalar, that would not merge.
There's already an interesting exception, I think, here that we would need for Apollo Federation because we support interface object.
Yes.
Which allows you to merge interfaces and object types.
Yes. We're going to put that into hopefully a version 1.1. But we
should call out that there are possible exceptions to this rule then.
Yes, no, we should maybe in any case.
I mean, semantic equivalence would still be fine, right?
Well,
because you see it as
not the way
interface.
it's stated here. Yeah.
Yeah.
Yes.
The formal description, at least, that needs to be relaxed. I agree that it's still semantic equivalence.
Yes, I know what you mean, but yeah. It's more the thing. What you guys have is for me like a default interface implementation, kind of just that you had the limitations of GraphQL, right?
That shouldn't. I mean, this is more about semantic field equivalence, right?
Now this is about type equivalence, and even in Apollo Federation, this is actually like it is, except for these interface objects.
Understand. All good.
Yeah. Okay. So we're gonna have to get out iron out the kinks here, but in general, this is the rule that we would put here, right?
Yeah. And I would name it. I would combine the names there. I would say semantic type or type semantic equivalence somewhere. Either prefix it, put it in the middle, or put it at the end. Because there's also the same for fields, right?
Of types, you mean?
Yeah, and for fields, the rules are a little bit different because, well, I think that's another topic. We differentiate between validation errors and hints, and like errors are sort of blocking. In this case, if you get a validation error during pre-merge, you wouldn't go on to merge. Like that's a rule that would actually block merging. But there are other rules that can be somewhat relaxed. And in the case of field types, for instance, we do allow you to merge fields that are sort of like nullable in one subgraph and non-nullable in another subgraph. But we do warn you about it. But it's important for evolvability of schemas as well, that sometimes like subgraphs are not completely in sync. And as long as we can guarantee sort of like that semantically it makes sense,
What's the outcome in the merge when you have it as non-nullable in one side and nullable in the other side?
Yeah, but this is also in the rule here, right? You can see this here.
Exactly.
If type's nullable, then this is
or it's more about what the expected outcome is, right? Because for output and input, it's the opposite as
exactly. That's the important rule. Yeah.
And the thing is that you should have probably the least restricting one than in the public schema. Otherwise, you will have runtime issues, right?
Yeah.
So how we have written the rules is more or less that we take nullability as a valid case in composition, that you can have it nullable in one subgraph and non-nullable in the other subgraph. But it's going to be in the composite types, it's going to be nullable if you have one nullable and one nullable. In the input type validation, it's the opposite. Then we fail if it's nullable in one subgraph and non-nullable in the other one.
Yeah. But I think we still want to warn people about it. So we still need the ability to sort of generate these warnings. I'm not sure if that should be part of the spec. It can also be outside of the spec, but for these kind of general rules, it might make sense to actually make that part of the spec.
Yeah, there's also a case with like unions and interfaces. So one field in a subgraph can refer or like have like a return type of, let's say, a dog, and the other subgraph, the same field of the same type could refer to animals. And that's compliant within Apollo Federation. And not sure how we like we haven't really talked about it. The same applies to interfaces, but like, we will. So we will discuss it, not that we will like do it, but like, we'll see. But basically this rule will be, I think will have to be more relaxed.
Yeah, we can always have a note there. We can I'm thinking like there could be any number of features where you would want to relax these rules, right? Like features that are provider specific, which might make it necessary to relax these rules in the composition tool of the provider. So we can have maybe a general rule, a general note that these are the rules as inferred from the directives that we have in the specification, but could be relaxed if there is need for implementation specific reasons. We will do the same for the execution. Everybody will have their own execution rules anyway, or optimizations. And we can have a general note that you can abbreviate from that.
Yeah.
Sorry, Martin, go ahead.
Oh, no, I was just agreeing.
I want to ask a question to Kamil about this. So just so I understand it correctly, you can return a dog from one subgraph, and you can return a cat from the other subgraph, but not on the same field, right? It's not magically union. Then you have to have a union which has the member dog on one subgraph, and you have to have a union with the member dog cat on the other subgraph, and then you would return the union, right?
Yeah.
Which still would be mergeable. It would be, if it wouldn't be mergeable, then the union merge rule would have to assert and say that something is odd, right?
Yeah, on the output that is possible, right?
Yeah, Martin knows it better probably, but like I call it like union intersection, which basically means that like if you refer to a union in like multiple places, the shared the members that are like intersection of those two like sets, these lands in the public schema, let's call it, and those are the really like runtime accessible types. So if you return something that is like out of this like intersection, it won't be like a runtime error, at least not in Apollo Federation. It will be just it will be nulled in some cases, obviously, but like
I'd have to see an example of this specific case, because I like my first
Yeah, so we don't have to go in the
Yeah.
specifics of these algorithms today. It's more like let's sort them maybe through, and then we go in the specifics on a one-by-one basis. We could even make separate pull requests for each of them and discuss them in detail and figure them really out.
I would
would
say we should make separate pull requests for each of them.
Yeah. But maybe we go through them just a bit. Okay, this is roughly an algorithm that we want to have. Like field mergeable is basically output field. The types are mergeable. We're going to have this rule, but it might have a lot of complexity to it. Makes sense? Yep. Because this way we can then also parallelize work at some point. That we discussed these and get quicker through them. Okay, so we have split this rule argument types mergeable and output field types mergeable. Because as Pascal also said, this has a bit an inverse. I don't know if the rules one-to-one exist in Apollo Federation. Like that.
Well, I think the naming is a little bit different, and we may have broken them up. I think in smaller rules. I think for exposition purposes, it might make sense to explicitly call out so that the difference in semantics between input types and output types, because that's sort of where these more specific rules come from.
So how this section is structured, you see, we have the composite type rules. And below there is an, I believe, a object type one, which is just for
input.
Then we have one for interface types, one for input object types, for enum types. So it's a lot of rules that we have written for all of the different types. I don't think we need this structure in the new specification, but in how it is now, it's basically we have rules for all composite types, for object types, for input object types, etc. And I believe if you open the input object type, we have pretty much the same rule. Input field types mergeable, which is just the inverse of the output field types mergeable because the nullability is flipped, right?
Yeah, and then in object type, you also have composite types. You also have the argument types mergeable. So if you're merging input types is a bit different as if you merge arguments. So these are separate rules.
Oh yeah. I mean the rules are separate, but I thought it might be helpful to start that section with describing the difference between sort of our treatment of input types and output types.
Okay.
So you better understand sort of where these specific rules come from.
And so where would we want to do that? Should we have in the pre-merge? No, we want to
have an introduction there where we have a rough explanation what kind of rules are coming, and then we go through the rules.
Okay, but do we want to have also structured them like we did originally, like in composite types, input types, and then substructure the rules, or do we want to just have a list of rules under pre-merge validation, or should we also substructure it?
Remember, did it work out well? Did we have one rule which had to be under two headings, or was it really easy to split?
I think it was easy to split. The one that is a bit overlapping is arguments and inputs, but it's also not 100% the same.
Yeah. So yeah, we can have the same structure. Types.
Martin?
Yeah, I mean, I don't think we have to decide on the structure right now. I think it's sort of, I think as we start writing these rules and writing the introduction to this section, we'll probably land on an organization that works.
What kind of structures did you use in Apollo? Or do you have names for them, or do you have just
No,
implementations?
I don't think we have a particularly detailed description of this. Like we have a description of the error codes that might come out of composition. But I don't think I'd have to look at our current documentation, but I don't think we have a section that actually explains sort of the different phases and the reasoning behind the different rules.
Okay, and Kamil, you guys did anything of structuring of these rules?
Not really. Just like the algorithm is like,
Okay.
Yeah, what we
Just
described.
making sure if there are better ideas for this. Just choose. Okay, then let's just list them, and then we can go over them. I mean, there will be anyway. Kamil often comes up. There's this particular case that also needs a rule, and then we add it as it comes along. Okay, so we have the argument types mergeable, and that is for output field arguments. Like it first there we can get better headings as we figure them out. Argument types. Yeah, we have argument types mergeable and arguments mergeable. What's the difference here?
The thing is that it could be that you have a required field argument on one subgraph and a different required field argument on the other subgraph. And the issue that you into is that you cannot merge them because you would have to remove them. You have only the set of the combined arguments that you can expose. So when you require an argument on each of the subgraphs, but they are not shared together, then you run into the issue that you cannot compute any valid queries. So that's more the set of arguments.
Okay, this rule is anyway not really specified. Explanatory text. This is blah blah. Yeah, this is
that works. That's all good. But when you scroll down to the counterexample, you see an example that doesn't work. That's still types mergeable, right?
Yeah. But here maybe
you have A, B, you have A and B.
I see.
Actually, you have to make them required. Otherwise, when you make them required, then they're not mergeable.
So are you saying you would merge them if they're? I don't think you would merge them if they're optional either, right?
Yeah, you would remove them if they don't match, right? If you have A, you would remove them. But if both are required, you cannot remove them because both subgraphs need one of the arguments.
Yeah.
And the validation rule says that it's not allowed to have a required argument on A and the required argument on one subgraph called A, required argument on the other subgraph called B.
And an exception there might be the use of require, actually. Because require gives you an alternative way of passing in, like they might have different required arguments.
These rules are all written without required, but that would be a post-merge validation rule, right? Because you need to have the context to see on.
Well,
you requires on the subgraph.
Yeah, you need the context to validate the require. But at this stage, you already know that a field is never exposed to the client.
You see.
So you can take that into account when you're deciding whether the field is mergeable.
All arguments that have requires on it basically don't count into the merge. Yeah.
But are you sure?
Yes. Because once you have because requires on the subgraph, right? It would be here.
Yeah, I understand. Yeah. Because
so we could immediately say, okay, B is required, so we take it out. It could still be that the requirement is wrong, but that's not validated here. We just validate
all requires. All argument with requires are just removed in this step.
Yeah, I skipped for the validation step.
Yeah.
But we still need the rule, but do we have a better name? Arguments are mergeable is actually not bad because it's not the argument types, it's the arguments that we. Okay. Required arguments cannot be internal. What is this about?
You cannot make a required argument internal unless you have a require on it.
Yeah, and that this is now like with inaccessible, can we make with inaccessible arguments internal? Martin?
So all internal in this
I-
classification are inaccessible.
I'm not entirely sure. Like we apply it to types, but I'm not sure if you can apply inaccessible to fields.
Yeah, you can.
Quickly verify.
No, sorry, to fields, but I mean to arguments. That was the question.
Yeah,
I think you
you
can as
can.
well. Yeah.
you can. Quick look at the docs, because now we have we wrote it originally with internal in mind, but since internal has a semantic shift now, this is basically required arguments cannot be inaccessible. But this is now a I would put that here in the source schema validation.
No,
I think the required argument is a bit ambiguous here now, because that could mean an argument that's sort of non-nullable, or it could mean an argument with a require on it.
Should be, yeah, Pascal.
We cannot do it there.
But why?
Inaccessible is cross subgraph, right?
If it's on one subgraph, it's
You're right. Yeah,
and it could be inaccessible but required on another, so it's also pre-merge validation rule.
Okay.
And yeah, I agree. Cannot be inaccessible.
Should we say non-null output field arguments cannot be inaccessible?
yeah. I do have to go in a few minutes. I think we're
we are through. It's good. We structured it, but we can already start on these guys here to put a bit more meat to it.
For next,
we anyway have a couple of these sessions.
Yeah, for the next session we can come with a more complete list. Then we can go through them and add all the missing stuff, because this is now just one view onto the problem without external shareable and inaccessible internal in mind. So let's see. And then I think a pull request per rule would be good. Some space and comment. Awesome.
Awesome. Okay, then let's end the meeting. Was great discussions, guys. And next week we can go on with the composite stuff, composition stuff, and then we probably have pretty good progress until the conference.
Awesome.
sounds good.
Awesome.
All right.
See you guys.
Well, thanks.